Hey, hi everyone. Good evening. I think a few people have to join in. Slowly, I'll see.
Hi everyone, good evening.
Yeah, there are a few people joining in. So, thank you all for joining. It's a pleasure interacting with you all once again. Today, we will be speaking about a project that our interns have worked on. This is in deep learning, AI related project. Here we will be seeing how face recognition is used in tracking employees' attendance. The solution is already implemented in the office of 360DigiTMG and InnoDataTex in Hyderabad. You are most welcome to walk into the office and experience. And the project is talking about emotion detection also. It's not just face recognition, but it is also speaking about identifying the behavior of our employee. The project is mentored by Sukumar and Shubha, our AI experts. And we also have the interns Siddhartha, Jagan, and Rohit. I would like Siddhartha to take over and explain about the project and what various things that they experience when they're doing the project and their achievements basically. So Siddhartha, please take over and you might want to present your work. Thank you all.
Yeah, thank you, sir. Thank you, Sharad sir. Can you hear me all? Can you hear me, sir?
Yes, Siddhartha, we can hear
Yeah,
you. So what
yeah,
should we want to
yeah,
discuss?
yeah, yeah. Good evening, everybody. I hope you are all doing fine. Yeah, let's move on to this project. Yeah, we have, the main focus of this project is to track the detect the person and to track his emotions with also like to uh, kind of sorry from my side. Yeah, the main focus of this project is to present the detect the attendance of a person and to track the emotions of that particular person. Yeah, here behavioral analytics part is respective to that. We are actually analyzing the behavior of the employee, like whether he is happy, he is sad, or while he's working with respect to his work. So yeah, with the happy, sad, these kind of emotions are captured. Later, these are analyzed by the user, and this project also can be used to like e-learning platform where we will be using this project to detect the emotions of the particular student to actually track his whether he is active in the class or whether he is sleeping. These kind of emotions can be uh, tracked through this project. Yeah, actually we were mentored by Sukumar and Shubha ma'am. They were actually given us a good opportunity to work on this, and our teammates are myself and Jagan and Rohit. Yeah, this is the main focus of our project. And coming to the objective of our project, first we are actually detecting a face of a person in a particular frame, whether he is on the webcam or whether he is on a any kind of CCTVs like that. So whether he will be first detecting the face of a person, and later this face, after detecting, is passed to the recognition phase, where he is recognized. Whether he recognized whether he belongs to he is a particular person or not, and later his emotions are tracked over a intensity or interval of time. Here, intensity or interval of time is nothing but if you take 5 minutes. So in that, the most repeated emotion is actually recognized and stored into the database. This is the main thing. Yeah, and coming to this main business, this project actually flows into three phases. First, it will be like face detection part and face recognition, and emotion detection. This will be flowing into three phases. Coming to the first phase, facial detection part, we actually collected 2000 image samples. So in these image samples, there may be a group of people or a particular individual people, individual person. So here we are actually labeling the faces in that images to train to with our model. So after labeling our images, so we actually get the annotation part. These annotations are nothing but coordinates of the faces. So these coordinates are captured in the annotations like XML or in the XML or TXT format, and later these are passed to SSD inception model. This is our pre-trained model, we actually trained our images on that. So actually it takes the input size of 300 and 300 into 3. It is a color image. We actually trained it using this model, and we got a loss of around until we trained until we got a loss of around 0.9. And 1,20,000 steps we have actually trained the model. So after training, after training the model, we actually tested it on our images, whether it is performing well or not. So after that, it was actually performing well with a within confidence of 99 percentage. So we actually and the challenges which we faced in this face detection part is that the images which captured by the web frame are actually in the low light. If the frames are captured in the low light, so this frame, so because of that, the detection part may sometimes give less accuracy. So to increase this accuracy, we actually use the autogamma correction part, where we actually enhance our image intensity, image brightness through this alpha value. Yeah, because of that, we can actually increase the accuracy of our detection part. These are the main challenges we have faced, and we have overcome the challenges with this autogamma correction method. Yeah. Coming to the face recognition part, we actually researched on three different topics, like VGG face and FaceNet over an open face. So these were divided between our teammates with these actually three models are actually researched, and actually I've took the open face model. So actually it is implemented in the mobile applications. So I tried it out on our local system because it is specifically designed for the mobile applications part. So and it will be having less parameters compared to VGG face and FaceNet. So it was performing very less, in the accuracy section in our local systems in the laptops like this. So actually we didn't go with this model. So we actually consider VGG face and FaceNet. And FaceNet was already implemented. It was already performing well. So we actually wanted to try out with the VGG face model. So this VGG face actually was done by our teammate Jagan. So in this VGG face, it actually uses the ResNet 50 architecture, where we will be actually getting the embeddings part, like feature vector. This is the VGG face part. So whenever the color image is sent into the VGG face, so it actually generates the embeddings, 2048 embeddings. These embeddings are unique for every image, every person. So if we want to compare between two persons, these embeddings actually tells us whether whether this person is same or different. This is the main recognition part we are using. Recognition, it will generate the facial embeddings part. Yeah, this is the main thing. So these embeddings are actually captured for every person and actually saved it in a database or pickle format, and these embeddings are later transferred to the SVM classifier. This is the machine learning algorithm which actually classifies our person is whether this person is same person or different person. It classifies our persons. This is the main use of this SVM classifier. Yeah, this is the recognition part, which actually goes through detection phase and recognition phase. So it will be detecting first here, detecting my face, and later it is recognizing me as a like seed. It is giving my name with confidence level of 75, a probability of 75% correct accuracy, and my emotion here is neutral. So it is almost giving 87% of accuracy. Yeah, this is the main recognition part. And the third phase we actually talking about is behavioral analytics part. Here we actually the detected phase is actually passed to the mini exception model. Here we have used the pre-trained model mini exception, where we train this algorithm with 7 emotions like angry, fear, happy, disgust. This kind of emotions are trained on, and whenever we pass an image to that, which is in the grayscale image, which these are the dimensions 48 into 48 into 1. These dimensions are actually passed to this, like this image is actually passed to the mini exception, where it will be identifying the emotions of a, like recognizing the emotions of that person. This is the main part of this mini exception model we have considered. And coming to this emotions detected, yeah, this actually you have to store the emotions to the database. Here, we are considering when user specifies to capture emotions for 5 minutes. So here, um, like for 5 minutes, so his 7 emotions are captured in 5 minutes. The maximum repeated emotion is captured, and it is stored into the database. Like if you say that happy is he's happy for his his happy count is high for 5 minutes. So his happiest emotion is recorded into the database. So in the next 10 minutes, if he is like sad, so if his intensity of that in that time interval is more for the saddest part, so that sad part is actually stored into the database with respect to his name and his IDs. Yeah, these are the actually emotions. This is my name, and yeah, I'm neutral uh, for every 5 minutes. We actually like for every minute we actually captured this emotions part. This one name, his ID, and emotions detected are automatically stored into the database, and later these are analyzed by the user to analyze the behavior analysis of a person. Yeah, and the main specialty of our project is we have actually implemented using OpenVINO. Like right now, I'm using a system with 4 GB of RAM and i5 processor. I'm using Intel. So OpenVINO only works with the Intel processors. So it actually enhance our inference. Like the predictions of our model will be faster compared to normal compared to normal models. By using OpenVINO, we have used 3 different models over here, pre-trained models. That too, they're having so many lakhs of parameter, millions of parameters we are using. Even after then, it is actually able to detect the frames in a very fast manner and store these emotions into the database. This is the main specialty of this OpenVINO. So we can implement this in our local systems. We can infer our predictions in a faster way. Yeah, this is the main importance of this. Yeah, and we have actually used to deploy. We actually deployed it using Flask in our local systems only. This is the main outlook of our project. So whenever the emotion is captured, whether his name is automatically stored into the database, and with his respective emotions, whether he is neutral, like see, you can see that I'm happy for our 1 minute over here. Like these kind of emotions are captured. So for future use, we'll be actually analyze the behavior analysis of a person. Yeah, yeah. Most actually achievements we have we achieved certain yeah things in our project is like in face detection part. Even a face, when a person is 10 feet apart, we can able to detect his face even in front of the webcam. This is our main achievement in the detection part. And in recognition part, yeah, we actually can recognize a person, yeah, even within in low light also. Yeah, we can able to recognize him with low light, and even with respect to emotions. Yeah, and we were actually mentored by Sukumar and Shobha. Their guidance was really good for us because uh, yeah, it was really good because actually we have to finish the project in certain speculated time, but because of the urgent requirement, we are actually able to finish it in 1.5 months. So because of their guidance, we actually we can able to finish the first phase of our project in a quite fast manner with their guidance. Yeah, that's all from my side, Sharon.
Hey, thanks, Siddhartha. That was wonderful. So, you want to have a demo? Do you
Yeah, sure.
present?
Yeah, I will. Yeah, I will be demoing. No?
Wonderful.
If you, yeah, if you can give me 2 minutes time, yes.
Sure, sure. Any
Yeah, sure.
questions, anyone in the meeting? Siddhartha, you might want to go on mute. Okay. Any questions, anyone, friends? So we will see the demo now. Jagan?
Hello, sir.
Hey, Jagan. Yeah, hi. Do you want to share anything?
Uh, no, sir. First we give a demo on that, and after that I will explain about the why we haven't integrated auto gamma corrections and how we have done. Like that, I will explain on that.
Wonderful, wonderful. So you might want to start off, Jagan. In the meantime, Siddhartha would prepare the system for the demo. You might want to proceed.
Okay, sir. Wait 1 minute, sir.
Yeah, Siddhartha, are you there? Hope you are setting up your system. In the meantime, any questions, anyone? You can, yeah.
Don't have one time.
Yeah, so Jagan, there's a question. What is the duration of the project?
So we have done it for 3 months as a 3 months project, and we have done a training alone for 5 to 6 days, and we have also done a manual annotation of faces like that. We have done it approximately take around 4 months. Yeah, 4 months.
So 3 months plus additional manual annotation and testing. In total, it took 4 months.
Yeah, including the implementation and UI development, all these things.
Wonderful. So yeah, there you go, Rakesh. It's 4 months duration. Okay. Any questions, guys? Yeah, you might want to post your questions. Waiting for questions, guys. Anyone? Yeah, just hold on for a minute, guys. We are gonna show you the demo, live demo as well. The system is being set up in the backend. Okay, there is a question from Parth.
Yes, sir.
What libraries are used for creating this project?
Okay. We had used TensorFlow 1.5 because at that time the 1.x version only have a support for object detection tasks. We have to use it. Yeah, yes, SGD inception, which is a lightweight model, which is portable to the mobiles also. And for UI development, we have to use Flask, and for the database, we used SQLite, like that. We use these packages.
Great. Parth also has a follow-up question. is there any specific system requirements to create and test this project? System requirements, basically.
Okay, for the system requirement, you have to need at least a 3 GP RAM system, and for in real time we can't make it more latent. For optimizing that, we had used OpenVINO concept, so it must be installed in a system to test that model. Uh, uh, More than that, not much thing is required for that.
Wonderful. And another question, Rakesh has a question. Is any data required to start the project?
Definitely. The data is the main thing over here. First of all, for the object detection, we have to train by ourselves manually. So we search for many open source data set, but we didn't find anything quite good. So we had collected some semi annotated data set, and we annotated the rest of the part. And after started training, and for face uh, face recognition, we had a pre-trained model of VGG, which is quite good. It has an advantage of detecting off-view faces also. So we have selected that. It is a pre-trained one. So we just tested it with our team members' photos, which we have collected by ourselves in a repo like that. We have done.
Great. Yeah. So there you go, Rakesh. The answer is yes, there is few of the data sets which are pre-annotated. Along with that, manual annotation was done and self images were taken to train the system. Parth also has a follow-up question. Is GPU necessary?
It's not necessary. So for that course only, we have implemented a open. It will take care of that, increasing the speed and the mobility like that stuff.
Very good. So, Parth, hope you got the answer. We don't need a GPU system because with the right, we had hardware crunch because we did not have GPU. And also we did not have, lot of people will not have GPU enabled systems. So for these people, it would be easy if you have a solution which can be executed on a CPU machine. And that's where the alternative OpenVINO was used. Okay, Siddhartha is ready. Siddhartha, would you want to share your screen? Is the demo ready?
Yeah, hello, sir.
Yes, Siddhartha.
Yeah, it is ready. Finish. Yeah, enable to
You can
share.
share your screen now.
Yeah, 1 minute. Yeah, can you see my screen, sir?
Yes, we can see.
Hello, everyone. Sorry for the delay. Actually, before I mentioned about the face detection part, right? So, yeah, this is the after we trained on the images. So this is our uh, predictions on our test images for face detection part only. So it is actually detecting face with around 97% on like this kind of accuracies. Yeah. And coming to the recognition part, yeah, as I mentioned, the face embeddings, right? So 204 face embeddings are actually generated using VGG face. So these embeddings are actually used to differentiate between with whether the this person belongs to particular person or different person. These are the actually results of that. So these are same images. So the cosine distance between these two, actually this is a distance metric we used to calculate between our future vectors, whether the if you are given the two images, so it will actually decide whether this person is same or not. Yeah, here cosine similarity is 1, so this is highest confidence interval because this is the same image. So yeah, and this part is the this is the same image only, but even if he has he even he is having beard right here, so it is detecting with an accuracy of around 77%. Yeah, this is VGG face model. This is, yeah, even this is same. Yeah, this kind of things are can be done with this future vector or embeddings. Yeah, now coming to the demo part. Yeah, this is the open window of environment. So actually, before I initialized it, yeah, we are actually using 3 different pre-trained models. So even after that, it was actually predicting it in a faster way. It is inferencing faster. And the system is actually 4 GB, so it is taking so much of time to. Yeah, I will run it once again. Yeah, this is the login page which you created. Yeah. This actually loading our pre-trained models through OpenVINO. Yeah, this is our info. Yeah. Yeah. Yeah, this is me. See. So it is recognizing me, my name as Sita Sid, and my emotion is neutral. This is my emotion is in happy state, so it will be recognizing with probability of 78% or something. And I will also show my teammates pics. Yeah, this is Jagan. Yeah, it is detecting Jagan as with accuracy of 60%, and his emotion is neutral because he is neutral. So around 80% of accuracy you can see over here. And if we can, if other photo other than this photo is given to our model, so it will be recognizing it as an unknown person. If the person is not registered, so it will be detecting as an unknown person. Other than that, other than which model is trained. and I can show you the emotions over here. Yeah. This is me. So these are the emotions. I'm chicken. This most of the time I am neutral. I can show you the emotions how it is actually recorded. Yeah, yeah, yeah. Here, yeah, here. Here the actually emotions are captured into the dictionary. Yeah, here neutral. Most of the times he's neutral over here. 34 in 34 frames he is neutral. In sorry, yeah. Yeah, in 33 frames, myself, I'm neutral over here, and two times it is recognized they are happy. If you take for 1 minute of time, here we actually given the 1 minute duration. So in not 30 seconds duration. So in 30 seconds, whatever the most repeated emotion is recognized, so it will be stored it into the database. Highest repeated emotion is stored it into the database. Here everything is neutral, so it will be storing it as a neutral part. So if he is happy, so it will be it will be showing as a happy emotion part. Yeah, yeah. That's all from my side, Sharath sir.
Hey, wonderful, wonderful, Siddhartha and Jagan. Great work, great achievement. So the system works without GPU, friends. That's the highlight of the project. We don't need GPU machines. As you've seen, 4 GB machine is actually executing face recognition algorithm here. Great. Wonderful, guys. So do connect with us. This is all for today. We will connect next week with another project presentation. Until then, thank you so much. And if you have any questions, you can always connect back with us on social media channels. And stay safe. Thank you all and good night, friends.
Thank you, sir. Good night.